So in this kinetic molecular theory, children, we did that partial pressure also. Last time we were doing Dalton's law of partial pressures, but now today we are going to do effusion and diffusion. Now let's try to understand the meaning of effusion and diffusion. Let's say this is a container, gas 1 in this container and gas 2 in this container, and you open the point at which they are connected. You can see this partition. So now you have created a gap in the partition. So what will happen? The particles will intermix. What are they doing? They are intermixing. So here intermixing of gases is taking place. Intermixing. And this intermixing of gases is called as diffusion. This is diffusion, right? But here, over here, the one container has gas, the other side is vacuum. Or we generally say very low pressure also, you can say, nearly vacuum. So when you open a small hole over here, what will happen? The gas will rush in this direction from high pressure to low pressure. The gas will go from high pressure to low pressure. Always remember, things they travel from high pressure to low pressure, from high temperature to low temperature. This is how heat is flowing. Heat is flowing from high temperature to low temperature. The wind, the air, it also goes from high pressure to low pressure. You know how these storms are formed. If you see the weather report, in the weather report, they are talking about the pressure gradients. They say a high pressure zone is created, so the storm is going likely to come. So what is a storm? Storm is when some area has high pressure of air and more amount of air, and then it goes from that high pressure, it will gush in the direction of low pressure with high speed. So when these gases molecules are going from this high pressure container to a container where there is hardly any pressure, that is called as effusion. Effusion. Diffusion and effusion. Is the difference clear? This is the only difference which we have to understand. Rest of the chemistry in both the cases is same. So gaseous molecules are moving, either they are intermixing. Diffusion is happening all around you. Your mother is baking a cake in the kitchen. You can smell the vanilla essence and everything in your room also. That is diffusion. You spray perfume. The smell of the perfume is spreading in the air. That is diffusion. Diffusion is whatever intermixing of gaseous particles in the air. That is diffusion. So diffusion is a regular phenomena, but effusion, where can I see effusion? You must have seen that small gas cylinders, the fire extinguishers. Fire extinguishers. So in the fire extinguisher, when you create the gas, there is a high pressure inside, high pressure. And then there is a small nozzle here. You press it and what happens? The gas, a high pressure gas, which is CO2, it comes out with great speed. So you can hear the sound also shh, like this. So that is your kind of effusion. So effusion is from very high pressure to low pressure, right? Or to vacuum. You must have seen gas cylinders, and if you press, like when you do that high pressure soda bottle, when you open it, can you see how shh sound comes out? So you can call it as effusion, right? So effusion and diffusion, these are two different terms, and that's the only thing which we need to know right now. Rest of the chemistry of effusion and diffusion is same. For example, if I say in this container, I have two gases. One is O2, O2 gas. Other is H2 gas. And O2 and H2 gases, they are undergoing diffusion, intermixing, right? So, okay, actually I don't want to discuss here. Let's say O2 and H2 is here and this container has N2 gas, N2. So can you tell me which gas will move faster from this container to this container? Which gas will have more rate of diffusion? H2 or O2? So you have to see about their molar masses. The gas with low molar mass will move with higher speed, low molar mass. Lighter, lighter particles, they move faster. And we'll see the mathematics also. But over here, if I say there are two gases, one is again oxygen and other one is, let's say, hydrogen. Now, let's say these are oxygen molecules. So when you open this small hole over here, you can see this. Which gas will come out first? Which gas will be here first? The small gas is H2 and this big molecule is O2. Again H2. It will be the first one to come out. So there are questions like this. If H2O2 gases are present as a mixture and you are asked to separate them, how you are going to separate it? So if this is a mixture of H2O2, you place another container in which there is no air, nothing, make a small hole and you will see all the H2 will come out first. So separation of gases. You are doing separation of gases based on rate of effusion. We call it as rate of effusion. And rate is the term which is going to deal with that the change per unit time. That is rate, right? So I'm going to clear it. Second. I have to share the document again because my pen somehow. Okay, now. So effusion, diffusion, clear. So this effusion and diffusion depends on the speed of the molecule. And speed was the part of your kinetic energy equation. Kinetic energy of a molecule is 1 by 2, the mass of the molecule multiplied by the square of the average speed, square of the speed. If I take average kinetic energy, average, then this is average speed, the mean speed, mean means the average of all the speed divided by total number of molecules. Can I say this? And if I rearrange the equation, because effusion, diffusion, you have seen depends on the speed. So what is U squared? This mean, what is it? It is 2 times kinetic energy divided by M, this M. If I say I'm dealing with 1 mole of the gas, then this M becomes molar mass. What is the mass of 1 mole of gas? Mass of 1 mole of any gas is the molar mass of the gas. Molar mass, right? So what is U squared? That is U only, mean. So this is square root of kinetic energy over M, right? So this is the equation. Higher the kinetic energy, more is the speed. But we already know from our other understanding that average kinetic energy from the kinetic molecular theory is proportional to temperature. So what is kinetic energy? Is 3 by 2 RT. This equation also we discussed. Yes, Anil. So kinetic energy is proportional to temperature and kinetic energy is 3 by 2 RT. Now from here, If I equate these two, if I plug in this value over here, then what is the root mean square velocity? This is mean, right? And it is the square root of 2 times 3 by 2 RT over M. 2 and 2 cancelled. So it is square root of 3 RT over M. So up to this, everything is clear? Liza, you have any question? You're Lisa or Liza? Okay, okay. Liza, right? Am I right? Liza. Is it correct? Okay, 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 fine. So it's fine. Okay, thank you. So can you just respond here in the chat when I'm asking questions, okay? So up to near up to what I have done, this is the mathematics I'm doing. Earlier I explained you the effusion and diffusion concept. Now I'm doing the mathematical part. So here the speed, which we generally call it as root mean square velocity. If you look at the book, they are writing like this, root mean square velocity. Why? Because you see, you took the square root, right? You're taking the square root. That's why the name is like this. Is equal to the square root of 3RT over M. Is it okay? This equation is important, children. Now look at the relationship between the velocity and the molar mass. So from this equation, I'm going to say the velocity is inversely proportional to the molar mass. Can I say that? The velocity is inversely proportional to molar mass, right? Okay. So what does it mean, Arjun? Higher molar mass, lesser speed, lesser molar mass, higher speed, which we already know. A lighter molecule moves faster. A heavier molecule will move slowly. But here mathematically we are proving it. So now we are with the equation. I'm going to clear it and writing the final equation that the speed of a gas A is the square root of 3RT over M. A is the molecule and Ma is the molar mass of the A molecule. Can I say similarly speed of B molecule will be the square root of 3RT over MP? Can I say that, children? These are two different molecules like O2, H2. Now, if both the gases are at the same temperature, then if I want to compare their speeds, I want to see that who is moving faster. So I will take the ratio. Speed of A divided by speed of B is the square root of 3RT over MA times this means 3RT over MB in the denominator, right? This is in the denominator. So I place it in the denominator. Rearrange 3RT, 3RT cancelled. Rearrange and you get this equation. Molar mass of B over molar mass of A. Square root of that is the ratio of the speed of A with B. This is the Graham's law. Graham's law. Can you calculate this ratio of hydrogen gas with helium gas? So how you're going to do it? You will take speed of hydrogen in the numerator, helium in the denominator, but the molar mass of helium will come in the numerator now here because they are inversely related, and molar mass of hydrogen will be here. Isn't it square root 2 nearly this value? And square root 2 nearly is 1.414. So can I say the speed of hydrogen gas is 1.414 times speed of helium gas? So which one has more speed? Hydrogen. How many times it is more? 1.414. We are good? Any questions? Okay. If I give you, let's say, a gas O2 and a gas O3, which gas will have more rate of effusion or diffusion? This Graham's law, which I just discussed, is applicable for effusion and diffusion equally. As I said, the terms are different and we need to understand the terms, and after that, rest of the chemistry is same. So O2 and O3, which gas will diffuse faster? Answer, which gas will diffuse faster? O2 will diffuse faster. What's the reason, Anil? Reason? Afan, your answers are not coming. Afan. What is the reason? Reason is simple language. I'm not asking exactly how many times, but you can do that also. Yes, what is the reason, children? Because O2 is lighter, smaller mass is less. And if you compare the rate of effusion of O2 over rate of effusion of O3 is the molar mass of O3, which is 16 times 3 divided by the molar mass of O2, which is 16 times 2. Take the square root. So isn't it nearly 4? Yeah, 16 times 2, this cancelled. You are left with 16 only, correct? So it's nearly is 4. So O2 will diffuse 4 times faster than O3. Is it right? The mathematics is right? Uh, Anil, you were also saying the same thing, right? Okay, can you do it in the calculator? 3 times 16. Oh, this is 2 times, sorry. This is 2 times 16. Oh, 1 second. I'm writing again. Please use your calculator and see whether it is correct or wrong. So the molar mass of O3 in the numerator and molar mass of O2 in the denominator, because they are inversely related, molar mass of O3 is 3 times 16 and O2 is 2 times 16 because oxygen is 16. Then take the square root. How much is the answer? What error I'm doing then? I was thinking in a different manner. Oh, 3 times. Oh, okay, 16, 6. Oh, right. Sorry. Yes, you're right. 1.225. I was thinking in terms of addition. Sorry. Yeah, Anil is right. Yes, is faster. O2 is faster. So these kind of questions will be there. So let's move on. So Graham's law is done. So what is Graham's law expression, children? I completely derive the Graham's law. If you remember, I started with kinetic energy is 3 by 2 RT, kinetic energy is 1 by 2, the molar mass, U squared. Compare these two, and the rate of effusion of gas A over rate of effusion of gas B is the square root of molar mass of gas B in the numerator over molar mass of gas A. So a high speed means less molar mass. A low speed means high molar mass. This is Graham's law, which we are going to use in case of effusion and diffusion. Okay, check here. There is a cotton ball full of ammonia, and this one is full of, oh, sorry, this one is full of HCl, hydrochloric acid, and this one is full of ammonia. These are gases. Both of them are gases. And ammonia gas reacts with hydrochloric acid to give ammonium chloride. Ammonium chloride. Ammonium chloride is a white solid. So when this is a clear gas, no color, no ammonia has no color. HCl also has no color. They are gases. And when they are mixing, they are giving you thick white fumes. Thick white fumes, because this is white solid. So wherever they are mixing, they will make a kind of screen of the white cloud. Like here, they are saying it's making here. The question is why this white cloud formation is closer to hydrochloric acid and away from ammonia. Why is it so? Why this white cloud is more closer to hydrochloric acid? See, one end is with hydrochloric acid, other end is with ammonia. Now hydrochloric acid will move in the direction of ammonia. Ammonia will also move in the direction of hydrochloric acid. So both the gases are moving in each other direction, right? Now the gas which moves faster will travel more distance. So which gas will move faster? Yes, Arjun. Which gas will move faster? Ammonia. Why? Because it's lighter. Check the molar mass of ammonia. What's the molar mass of ammonia? Is 17 grams per mole. So ammonia is going to move faster. And by the time hydrochloric acid has moved only this much distance, ammonia is already here. Like two cars, one car moving with high speed, other car is moving slowly. By the time the slow car is out of the garage, the other car is already in front of the house, right? So that's how you can compare the speed. And they will meet closer to hydrochloric acid. So these type of questions can be there. This is an experiment to show the diffusion of ammonia and hydrogen chloride. To show that diffusion depends on molar masses. Is it okay? Can we do this question? Zero 0.5 mole of helium, 0.5 mole of neon in two 10 liters container. So there is a 10-liter container here, 10 liter, the volume. Temperature is also given. This is also 10 liter. Temperature of both the containers is 25. Each container has a pinhole opening. Like there is a small hole here and there is a small. This is a very simple question. One container has helium, other container has neon. Read the question, make this picture in your mind or on the paper, and then answer. Which gas will escape faster? And pick up the correct reason. Okay? Yes. Very good. Perfect answer. A is the answer, children. A, yeah. Because we were just discussing that it's the effusion diffusion which depends on the molar masses, and helium has lesser molar mass than the neon gas. Read this question. So when you are reading the question the way I'm reading and making a picture in my mind and on this whiteboard also, a metal tank, so let's make a tank which has O2 gas. If I add more O2, more O2, see, I'm making the picture of the question, but I'm not changing the temperature. Temperature is still the same. What about volume? When I add more O2, volume will change? No. The question is telling me how? Because they said it's a rigid tank. Rigid means no change in volume. So from this information, the language of the question is telling me that there is a rigid means constant volume, like a metal tank. Metal tank. I think that's what they are saying. So volume will not expand or contract. And temperature is not changing. Volume is not changing. I'm adding more O2. So what will be the change? So when you add more O2, okay, she's right because molar mass is not changing. Temperature is not changing. If temperature is not changing, then kinetic energy is not changing because temperature and kinetic energy are directly proportional. If temperature is not changing, kinetic energy is not changing, molar mass is not changing, then velocity is not changing, right? Because velocity of the O2 gas is, what was the equation? 2 times kinetic energy over m square root. You remember this equation from this one? That kinetic energy is 1 by 2 mu squared. But this kinetic energy is average. So that's why we said average speed. So this speed is average, the square mean square root velocity. It is the mean of all the velocities. So what is not changing? M is not changing, kinetic energy is not changing. Is it okay? What is molar mass, Anil? Mass of 1 mole, right? So it's not changing. Here I took this molar mass. Is the molar mass of this O2 which you are adding and the molar mass of O2 which is already there, is it different? No, it's same, right? The total mass of the container is changing, but not the molar mass of the molecule. Okay, why this B is wrong, children? Why the B is wrong? No, B is not constant. Yes, anyone? Afan, why B is wrong? B is not constant. Only volume is constant. Then you know the ideal gas law, P equals to nRT over V. R is not changing, T is not changing, V is not changing, but is this N changing? Yes, you're adding more molecules and pressure is directly proportional to number of molecules. So moles are changing. So as number of moles are more, what happens to number of collisions? Number of moles are more, what happens to number of collisions? Number of collisions increases. As number of collision increases, pressure, which is defined as force per unit area. Anything which is not clear to you, Liza, then please write down here, okay? Is the number of collisions. We all are going to help you. Any word which is not clear per unit area. That is pressure. We are good with this? They should have given the pressure of the gas increasing. Why the volume is not changing? Which part of the question is telling you that volume is not changing? Rigid metal container, this part. Is this correct? No. Why? Because they are saying that additional oxygen is added. Average distance between the molecule increasing. Why this is wrong? This is the metal tank. These are the molecules, right? You are adding more O2. So what happens when you add more O2? When you add more O2, what happens? Is the distance among the molecules increasing or decreasing? Yes, so it should be decreasing. So please understand when these type of questions are there, work with every option, at least when you are learning. I'm not asking you to work with every option in the exam, but in the exam you can go, if you are very clear that what is the right option, you can go for that. But otherwise, work with every option and see why these options are ruled out. That will make you a better learner. Moving on to the next question. See this question. Ideal gas is cooled from T1 to T2. Temperature is changing. Constant volume. Let's take a rigid container. Afan, rigid means fixed volume, right? Which of the following values of the gas will decrease? The average molecular mass of the gas, the average distance between the molecules. So what happens? Volume is not changing. These are the molecules. Is the number of molecules changing? Number of molecules changing? No. So with the decrease in temperature, what happens to kinetic energy? With the decrease in kinetic energy, what happens to speed? The velocity. Yes, very good. So the speed will decrease. So, and what happens? The molecules can come closer also. But of course, volume is not changing. But with the decrease in temperature, attraction, what happens to attraction? Attraction among the molecules, it increases because molecules are moving less faster. So as the attraction increases, molecules will try to come closer because at high temperature, attraction is less. Temperature is going to break the attractions. You start reducing the temperature like as you go from ice to liquid water. So what are you doing from going from ice to liquid water? You are raising the temperature. So as you raise the temperature, attraction becomes lesser. But as you go from liquid to ice, you are dropping the temperature. As you drop the temperature, attraction increases. So we are good with this. So as the attraction increases, molecules will come closer. They will come closer. Okay. So let's move to the next. You know STP conditions? STP. What is STP condition, Afan? Arjun? STP. Yeah, I'm calling the name, but otherwise all of you can answer it. No, what is the temperature at STP? What is the pressure at STP? If I take 1 mole of the gas, 1 mole, then the volume is 22.4 liters. Temperature is 273 K. Yes, Afan, your answer is not here. Yeah, good. And pressure is, Afan? Pressure? 1 atm. That's the pressure. 1 atm. Very good. So temperature, pressure, and if it is 1 mole of gas, then it is 22.4 liters. Right? So answer, what's the answer here? Same. Same. What is same? Temperature is same for hydrogen and oxygen. So what will be same if temperature is same? If temperature is same, kinetic energy is same, right? This is same. What about velocity? Is velocity going to be same? This B part, is it going to be same? Velocity? No. Which one will be moving faster? Which molecule will be moving faster? H2. Because it's lighter. They have the same kinetic energy, but different velocities. Volume, is volume same for both of them? The number of moles of H2 are 0.50. The number of moles of O2 N is 1.0 mole. Can you tell me what is the volume of H2 at STP with this much number of moles? Take this ratio, this one. So 0.50 times 22.4 divided by 1. So isn't it 11.2 liters? And what is the volume of O2 at STP? It is 1 mole. So if the number of, here I'm teaching you different questions based on the concepts which you know. I'm converting every part as a question. So 0.50 mole of H2, that is half moles than this one. If temperature, pressure is same, and if the number of moles are halved, volume is halved. If number of moles are made 3 times, volume will be 3 times, provided temperature, pressures are constant. You're getting it, children? Effusion rate. Is effusion rate same for H2 and O2? No, it is not same because same is this only. So definitely all these are not same. So which one is going to have higher effusion rate? H2. What about density? They are in the, this is in how much volume? 11.2 liters, we calculated, right? And this one, 22.4 liters. So do you think their densities will be same? Can you calculate the density of H2 gas? Density of H2 is mass of H2 over volume of H2. What is the mass of H2? Is mass given? No, no, no. Anil, it is 0.50 moles. So 0.5 times 2. That's the molar mass. Grams per mole. The moles given are 0.5 divided by 11.2 liters. And what is the density of O2? Is mass of O2 over volume of O2 gas. What about the mass of O2? No, no, Anil, again wrong. O2, 32 grams. It is 1 mole, right? 32 divided by volume of O2, we calculate it as 22.4 liters. So which one is more denser? H2 gas or O2 gas? Which gas is more denser? Yeah, like this. Okay, let's see the next question. So I hope that you see that in that question, the previous question, if I go back, I converted A, B, C, D, E, all of them into questions. And we calculated everything. A, there is no need of calculating. We can say, okay, that's same. But we compared the molecular speed by using effusion, diffusion law, Graham's law. You need not to worry about the name that Graham's law, but you should know that what is effusion, diffusion law, the mathematical formula. Volume, we calculated volume by using STP condition. Then we compared the effusion rate based on molar masses. And then in the E part, we calculated density. So we did different varieties of questions. Now check this question, children. These are the Maxwell-Boltzmann distribution curve, which we did in kinetic molecular theory. Here is the speed. Here is the number of molecules. What is the most probable speed here? The most probable. Which part of the diagram is representing the most probable? This one. The most of the molecules have, see, most of the molecules have, these are the number of molecules have this speed. And this one represents molecules with very, very high speed. This represents molecule with low speed, right? You're getting it? And this is the most probable, most probable. What are you expecting the average? Where will be the average speed? Average is the sum of all the speeds divided by total number of molecules. So where can be the average? Just see the area. Put a line here. And draw the area under this curve. This one. And draw the area under this curve. Can you tell me which molecules are more? The one with less velocities or the one with more velocity? Mhm. Yes. So the average will be lying in here, somewhere here. Average will be on this side. If the graph would have been like this, then if this is the midpoint, then you can see that more molecules are there with high speed, right? So in that case, average will be lying in this direction. If the peak is tilted in this direction, then average is slightly on the higher side. If the peak is tilted in this direction, like this, then average will be more in this side. So they may or may not ask this question about the average. Afan, are you clear about it? The most probable speed is always in the center. Most probable means the speed of maximum molecules. Average will depending upon in which direction the peak is tilted. This distribution curve, if it is more tilted in this direction, then average will be over here. Like in this case is here. But if the distribution curve is more in this direction, the average will be slightly here. So it will be very closer to most probable. But rest will depend on the which molecules are more, the more with less speed or more with high speed. We are good? Okay, answer this question. This is the speed of N2 molecules. They are asking you to make O2 on the top of it. So which one has high molar mass, N2 or O2? O2. So O2 will be moving faster or slower? If it is moving slower, then the graph will be more to the left or to the right. It should be more to the slower side. This is slower speed. If the graph is going on the left side, because I was telling you this also, and I explained you earlier also, the area under the curve, this curve, this is the curve. Area under the curve represents the number of molecules. If we have taken the same number of molecules, this area is representing the number of molecules. Arjun, where are you? You are there, Arjun? Area under the curve, number of molecules. If I say I have taken same number of molecules, this is N2 and this one is O2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. I think I have taken 10. Let's say 10 this and 10 this. So don't you think that the area under the curve should be same? Because number of molecules are same. Then in which direction the curve will shift for O2? For O2, the curve should be on the direction of low speed. Low speed means like this. And because you are going in the direction of low speed, the width is decreasing, so height will increase. Arjun, you are not in the class, you are not responding. See like this, right? Anil, which option is right? You cannot have same areas, right? And this thick line is nitrogen. Thick line is nitrogen. Dash is for oxygen, but oxygen is not moving with higher speed. So this graph is totally out. This graph is totally out. We are struggling with A and B only because the number of molecules are same. So when you are shifting your curve to the low speed area, then the width is decreasing. You can see the width. So height will increase. Okay. Moving on, children, to the next question. Okay, check this. So these are the questions based on Graham's law. Afan, check. Helium, argon, neon, pinhole sized leak. So immediately check who will move faster. Which gas will move faster from that tank? Which gas will effuse faster? Helium. So this is the tank. In this tank, there is a leak here. There is a leak here. And there was helium, neon, and argon. They all are at the same pressure, let's say. All of them are at the same pressure. And the gas starts effusing out. So you are saying helium is the first one to come out. This is the first one. Now they are asking once the gases have come out, equal number of moles. Okay. What does it mean? I missed this line, equal number of moles. So moles are same, N is same, tank is same, so volume is same, temperature is same, they have written room temperature. Temperature is same. So what are you expecting for the pressure? Which is nRT over V. All these are same in all the three cases. So don't you think that the pressure is same for helium, argon, neon? Initially, before the leak, the pressure of helium is equal to pressure of neon is equal to pressure of argon before the leak. Now there is a leak from here. And then we know that this gas is coming out faster, right? So this is before the leak. Then which gas will show you now minimum pressure in the container? Which gas will be left minimum in amount? Isn't it helium? Because it's moving faster, so its number of moles of helium coming out will be more than neon, then argon. So what's the answer? What is the pressure after the leak? This is before the leak. What is the pressure after the leak? This one. Why? Afan, why is it so? Yes, Afan, why is it so? Because helium is the one which has moved out more. The amount of helium left. Liza, your answer, please. Why is it so? Helium left is minimum and argon is maximum. Liza, are you there? Hello? Okay, ask your question. Okay, tell me, is it clear, this one? Before the leak, the way I explained. Okay. So it means initially they were all equal, right? Now which gas will move out faster? Liza, which gas? Helium? So don't you think if helium is moving out faster, so after the leak, the amount of helium will be minimum, right? By the time you seal the leak, the helium left will be lesser than neon, and neon will be lesser than argon based on the speed with which they are moving out. So the pressure which is defined as, now the number of moles are not same. Number of moles are changing. So if number of moles are changing, then pressure is changing. So the pressure of helium will be minimum because moles are minimum. Rest all are same. Earlier, when I started the experiment, they were equal in number. But once the leak is there, by the time we close the leak, we observe that pressure of helium is minimum and argon is maximum based on diffusion law. Is it okay? Can I move to the next? See this question, please. A, B, C, D, E. All the containers are 1 liter. So don't worry about volume. Volume is same. Greatest average speed. Speed depends on two factors. What are the two factors on which speed depends? Kinetic energy, which depends on temperature, and speed also depends on molar mass, right? Molar mass, the mass of the molecule. Now, based on these two factors, temperature and molar mass, which we can easily work, which gas is lightest? Afan, work with me. Which gas is lightest? The gas which is lightest is N2. Now pick up the gas, lightest gas at the highest temperature. Highest temperature is 50, right? Pressure has nothing doing with it. Pressure, amount, nothing doing, right? Because speed depends only on two factors, temperature and molar mass. Nothing doing with the pressure, volume. Volume as it is not changing. So, with the greatest average speed is N2 gas with highest temperature, and that is a fan, not D. D is not even N2. Why did you say D? These are ruled out. Ruled out. I'm just comparing A and B. Yeah, okay. But is it clear, Afan? Yeah, you're right. You're writing correctly. N2 at Liza, is it clear? It's not D, right? You have any question? So when I looked at the molar masses, yeah, when I looked at the molar masses, I ruled out O2 immediately. So three containers are out of my sight. And then I'm just working with N2. When I'm working with N2, only N2, then I just looking at the temperature. So write down this in your notebook. Speed depends on two factors, kinetic energy and the molar mass. Higher the molar mass, lesser the speed. Graham's law, right? Okay, moving on, children. Next question. Please read the question carefully. Make the picture, the diagram, everything. When you are reading a question, diagram will help you. There is a container with 1 liter helium gas, temperature 25, pressure 1 atm, combined with another container which is also 1 liter, and this is neon gas. And temperature same temperature, same pressure. So both the containers are 1 liter, 1 liter. Both the containers are at the same temperature and both the containers are at the same pressure, right? What can you conclude from here? Two containers of gases at the same temperature, pressure, volume. What does it mean? Means same moles. They have the same moles because N equals to PV over RT. Ideal gas law. Ideal gas law. Pressure is same, volume is same, R is so without even reading the question, I'm just making the conclusion, oh, these two containers have same number of moles. But do you think both the containers have the same mass? Moles are same, but mass is same? Yes or no? Which one is heavier? Which one is heavier? Neon, yes. Now let's see the other things. Which of the following statements will there be any change in the speed when I'm combining them? Will there be any change in the speed of helium and neon? Afan, will there be any change? Answer the first part. No, there will be no change because we are not changing temperature. Yes, good, no change. The average speed of the neon atoms increases when the gases are combined. No, there will be no change. No change, right? So what is the answer? Just see, because temperature is not changing, molar masses are not changing, so they will be moving with the same average speeds. Helium, neon, no change in their average speeds, and no change in the kinetic energies because temperatures are same. So both the gases are at the same kinetic energy, and when you are mixing them, there is no change in the kinetic energies. Is it okay? Okay, this question, children. So when you look at this Maxwell-Boltzmann distribution curves, these are called as distribution curve. I gave you the name earlier also. Always check what is written here. Sometimes they are writing it kinetic energy, and in some cases they are writing speed. So explanation will be different. Right now they are saying speed. So look at these graph. Let's say this is A graph, this is B graph, this is C graph, this is D graph. Can you tell me in which graph the molecules are moving fastest? In which graph the molecules are moving fastest? Fastest means which graph is more to the right. Afan, which graph is more to the right? Yeah, D. The molecules are moving very fast there. And in which case the molecules are moving very slowly? A. So if I say, let's compare their molar masses, because they are saying these graphs are at the same temperature. And this is speed. And I just told you that the speed depends only on two factors. What are those two factors, children? On which speed depends? It depends on temperature. And yes, very good, very fast, very good. Temperature and molar mass. Speed is directly proportional to temperature, but inversely proportional to the square root of the molar mass, right? Speed directly proportional to temperature, and speed inversely proportional to the square root of the molar mass. Correct? So, can you answer this now? Pick up the answer. Okay, before you answer it, which gas is the heaviest? Let's arrange them according to their molar masses. A is the lightest, then B, then C, then D. Okay. Which one is the right explanation? Mm-hmm. But is this ranking it? Because they have the same kinetic energy. They're asking which one is going to rank them correctly. Ranking, the way we ranked it. Which one has, if I say they all are present in the same container, they all are present in the same volume. This is the container, 1 liter. 1 liter A, 1 liter B, 1 liter C. Which one is going to have the highest density? D. This is ranking, right? Oh, did I write this correctly, children? Yeah. So as the speed, no, the density of the gas increases. Yeah, that's right. And D, the molecular masses, because the gas molecules have the same average kinetic energy, mass can be calculated. Okay, that is also right. That is also right. So out of A and D, one is correct. So is there any error in this statement? Density increases as speed decreases. As speed decreases, molar mass increases. Right? But okay, now D is also right and A is also right. But I'm going to rule out A, children. I'm going to tell you why. I'm going to rule out A because density depends on volume also. And they are not mentioning anything about volume. They said they are at the same temperature. They mentioned this, but they didn't mention volume. So I don't know what's the volume of these gases, right? So that's the reason that I'm not going for it's the right explanation, but I'm not going for this option because if the volume changes, then I cannot compare the densities. If they are in the same volume, then yes, I can compare. But they are not saying they're in the same volume. So just leave this option and go for this one. So Liza was right. D is the right option. Anil, is it okay? Afan? See, A and D are correct explanation, but with the A, we have a technical glitch that they have not given us the volume. So I'm not sure whether the gases are in the same volume. They can be in different volumes. So that is the reason we'll say, okay, let's not do this. Let's go for this. We are moving to the next one now. Let's check this. Oh, that's very simple question. They're talking about average kinetic energy. Just look at the temperature and the temperature. Just don't worry about anything else. Temperature and the temperature is same. So they all are with the same kinetic energy. F1. They are all with the same kinetic energy. Okay, this question I just discussed with you. You remember the heavy gas and the lighter gas, they are moving towards each other and they will meet and make the product. The product is appearing to us like a thick white fumes. So the gas which is lighter will move faster, the gas which is heavier will move slowly. Now, exactly based on the same concept, here is a question. So first read the question. Solid closest to the center of tube here. So how can you have exactly in the center? Not exactly, means nearly center. How can we have nearly in the center? If they move nearly with the same speed. And how can they move nearly with the same speed? If they have nearly same molar masses, right? So check. What are the gases with nearly same molar mass? What's the mass of HCl? 36.5. This one? Carbon is 12, nitrogen is 14, and 5. I'm just checking nearly, not very accurately. How much is this? How much is this, children? 31. This is 36.1 and this is 31. What about this? Same 36.5 and this one 17. Big difference, right? Big difference. In this HBr, HBr is 80. This is 81. And this one we just calculated 31. This is 81 and this is 31. So what's the answer? A is the answer because their molar masses are very close, so they will be exactly nearly in the center, but more in the direction of HCl or HCH3NH2. More in which direction? Slightly more in which direction? Slightly more in the direction of HCl. If this is HCl, so this circle will be made slightly more. Circle of the product, more in this. And in this case, it will be more in which direction? This is actually 17, not 13. This one. NH3 is 17. It is more. HBr is trying to move, and by the time ammonia is already there. Okay. Very popular question, children. Check this. This is how you should make the picture when you're reading the question. Volumes are different. This information is here in the question. Temperature is constant. Temperature is not changing. Are you talking about the previous question, Anil? But how come HCl is moving with higher speed? Speed depends on temperature and molar mass, right? Temperature is same. They're in the same container. Yes. Give me 1 second. Check this one. So here they are saying the temperature is same. Even the air, this is also air, this is also air. So there is no change. The molar masses also. So what will happen to what do the volume and pressure effect on the kinetic energy? Is there any effect? If temperature is constant, so they have made such a big picture, such a big explanation, and answer is temperature is same, so kinetic energy is same. So if there is some big explanation and big picture, don't get scared. Maybe I have to give some very complicated answer. No, these big pictures, big explanations are there to get your attention, that you should read it carefully. Otherwise, question is very simple. Let's see this one. Afan, you have understood the previous question, am I right? Because in the previous question, temperature is not changing. You keep changing pressure, you keep changing amount of the gas or the volume of the gas. The kinetic energy depends only on temperature. You change temperature, kinetic energy changes. Question 13. Very simple question. You have to make helium gas on the top of this graph. Helium, heavy, speed will go in the direction of left direction, low speed. So helium molecules will have, atoms will have less speed, but as you're moving in the left side, the height will increase, isn't it? So which one? Afan, you're there? Yeah, you have understood this? Okay. Question 14. The pressures are given, but pressure has nothing doing with the speed or with the kinetic energies. So don't worry about the pressure at all, right? So you're going to compare the speed based on their masses, and you are not going to worry about the molar mass, the total mass of the container, because speed is one particular atom. Like for example, this is an atom, this is another atom. The speed of this atom depends on its mass. So which I can calculate from the I can compare the molar mass. Molar mass divided by Avogadro's number is the mass of this atom. And this, if let's say this is helium and this is neon. So what is the mass of this atom? The molar mass of neon, which is I think 20 point something, divided by Avogadro's number. What is the molar mass of, what is the mass of this helium? So it is per atom. So that is 4 divided by Avogadro. That's the reason we can easily compare the molar masses to know which one is moving faster. So Are they at the same temperature? Yes, they all are at same temperature. So it means all the gases are with the same kinetic energy, right? So these gases we know, but this one is missing. This one is missing, but they are not talking about this third. Can you see? 1, 4, 2, 1, 2, 4. So they are not talking about it. Just leave it. Yes, please. Helium. So again, they have given a complicated table. There is a question mark. And then in the question, they are not talking about that particular column. That option is not there. So leave it. Don't waste your time on it. Right? So you should be smart to save the time also during the exam. Moving on. Yes, very fast. This one I'm not helping you, waiting for your answer. So see what is the change. What change they are doing, children? They are increasing or decreasing the temperature. They are decreasing the temperature. Temperature decreases, kinetic energy decreases, speed decreases, and the graph will shift to the left. The height of the curve will increase. So answer is D. Yes, all of you are right. Afan, your answer is not there. Okay. Now this is the next topic, deviation from ideal gas law. Arjun, too late. I was calling your name and you were missing. Where were you, Arjun? Celebrating your festival? Arjun? No, you were not in the class. You didn't answer anything. I called your name. I told you that if you have to go out somewhere due to any reason, please inform me, right? So that I stop calling your name. So this is the next topic, 3.6, deviation from ideal gas behavior. So children, because we are left with very less time, so I will start this topic in the next class. But today we did plenty of questions on diffusion, effusion. This is the most important graphical questions like these distribution curves, everything. I hope that's crystal clear to all of you. Graham's law, effusion, diffusion. Is it clear? Okay, that's good. Now, in the next class, we'll do deviation from ideal gas law. Here, there is no question based on mathematics. All the questions are based on basic understanding, and it's going to be very simple topic. So see you in the next class, and may I request Lesha to stay back in the class? If you have any questions, you can stay back. And Arjun, have a nice day. Enjoy your. I'll see you next year then, Arjun. Yeah, bye bye. Hi, Lasha. Can you unmute yourself?
Yeah.
How
Hello.
was the class?
I found that really nice. I think I was just surprised because I thought it'd be Unit 4, but then we were just reviewing Unit 3.
Say again.
Um, I thought this class was gonna be about Unit 4.
Oh, no, no. We are actually finishing Unit 3. I
Oh,
know
okay.
that I missed one of the class last week, but somehow
Um,
there are some students in the class, they are not interested in extra classes.